Um, Welcome to the lunch series continues. We thank you for joining us today. We have an exciting program today with combined power and heat energy efficiencies. But first, I'd like to go over a couple announcements for the IEEE Consultant Networks. We're in conjunction with the IEEE Seattle section and the Power and Energy Society IEEE up in Seattle. But we have folks from all over the country joining us today, mostly in California and up and down the Western service half. Couple events coming up at Tech Talk with Chris Wyden. He's America's #1 influence and impact strategist. He's one of the Inc. magazine's top 100 leadership and inspirational speaker. And he will be talking to us on improving and acing our presentation skills on Tuesday. That's our Tech Talk. And you don't want to miss that. You can sign up on vTools today. Next month, we are doing a joint venture with our San Diego Consultant Network partners. And we'll be speaking on AB5 and the gig economy, how the Brillo and Dynamax decisions in California may affect our consultants up in the Seattle area. So it's starting a precedence. Once again, I'd like to thank our sponsors, Data to Develop, Cheryl Christensen. She did a presentation, Tech Talk, early in the year, Arcline Safety Solutions with Stephen Bowers. He also did a virtual presentation for us in Arc Flash Electrical Safety, which will have a presentation next month on the NFPA 70E, changes to the NFPA 70E 2021 version, so you don't want to miss that. Today's session is being recorded, and at the end of the presentation, whoever's left, we have some nice gifts. Salis O'Brien coffee mug, Salis O'Brien kitchen utensil. So if you hang in there, we're going to have a drawing for that. Our speakers today are Dave Muller with Western Energy Systems. If you're not speaking, please mute your computer. And Phil Baldwin with N2 Energy Solutions. Dave is a multi-dimensional quick study benefit and diversity professional in his career. He's been in energy and focuses on making this place a better world. He thrives on challenging opening new markets and domestically and internationally. He builds relationships, crafts strategies, and boosts business and articulates compelling message for opening new opportunities. So he's a great guy. Working at the Western Energy Systems, he focused on client development and recruitment, established long-term relationships, and provide solutions to energy-related challenges. His previous business development brought him all over the world: Kenya, China, Aruba, Indonesia, Singapore. Great places to be. During those missions, he engaged with the city leaders and gave solutions to issues that came up. He thrives on customs and understands the issues, and he works collaboratively, crafting ideas for folks like us. He enjoys business development, government relations, business strategy, media relations, and project management. Our second speaker today is Phil Baldwin, N2 Energy Solutions. He has 25 years of senior management and leadership positions in companies specializing in energy project development. So he designs engineering and does construction. Since 1998, he was focused on distribution generation, combined heat and power, and renewable energy projects in the agro business and food beverages manufacturers. And he's going to give some case examples today, so you don't want to miss that. Take it away, Dave.
All right, thanks, Mike. Hey, I appreciate everybody joining us today. Again, my name's David Muller. I'm with Western Energy Systems, and I serve as one of the business development managers. We're joined today by my colleague and good friend, Phil Baldwin with N2 Integrated Energy Solutions, and we'll be talking about combined heat and power. Again, I wanted to thank everybody for joining us today in one of the most unusual summers I think we've ever experienced. So hopefully this will be a respite from everything that we've been experiencing the last few months, and I hope it's worth your time. So today's agenda: a quick overview of Western Energy Systems and a brief introduction to combined heat and power. I'll present that, and then second up will be Phil will be presenting a much more in-depth view of combined heat and power, taking advantage of what we've learned from our relationship with a specific client by the name of B. Braun Medical, which is here in Irvine, California. It's a significant project in it's the best way to really get a grasp on combined heat and power using a case study. Once that's complete, we'll get into a Q&A discussion and hope that you have questions and comments. We're certainly interested in hearing what you have to say. So we want to begin with our value proposition. This is part of the background on Western Energy. We're the solutions provider and we're project developers. We view ourselves as a collaborative partner from concept to completion. And then we take it all the way to the entire duration, the life cycle of the project. We have a complete team, Western Energy Systems, while we provide the equipment, including balance of plant, long-term maintenance and service. Again, the N2 Integrated Energy Solutions is an integral partner of ours and is our project development partner, and they're also EPC for our projects. As you can see, we also do commissioning, which is the critical portion of the project with remote monitoring. My Plant is essentially a phone application, so that once you've got My Plant on your phone, you can monitor your entire plant that we've put in. And lastly, I want to emphasize that we do quarterly performance reviews, certainly on every project, but that is also monitored by our regular visits on the service side. So a brief overview of our company. We're actually part of a $200 million company called Penn Power Group based out of Philadelphia. There's 4 divisions. You've got Penn Power Systems that focuses.
Hey, Dave, can I interrupt?
Yes.
Can you show your slides? I only see the first slide.
Oh, I'm sorry.
Enable editing. You got it up there at the top.
Okay.
You need to get into the presentation. There you go.
Sorry about that. Thanks for catching that, Mike.
Now I only see the folks. You need to get the slides back up.
Yep. All right. Can you see that now?
No, not yet.
Can you see the first slide?
Not yet.
Sorry, folks.
There you go. Hey, there you go.
Okay.
There it is.
Got that now?
Good job, Nick. Nope.
See the agenda?
Value proposition, brief overview of our business.
Okay, great. Thanks. Mike, I appreciate you pointing that out. That's a rather critical factor. Thanks for your patience. So what I was saying is that Penn Power Group is our parent company. There's 4 divisions. You've got Penn Power Systems. They maintain 6,000 standby diesel and gas generation systems. You've got Northeast and Western Energy Systems. And Western Energy Systems is the Jenbacher distributor for the West Coast, and Northeast does the same thing for the Northeast corridor. We've already talked to some extent about N2 Integrated Energy Solutions as one of our divisions as well.
Bill?
They make it possible.
Is now exiting.
They make it possible for us to do full turnkey projects. Last item is Sigma 6 Solutions, and they're involved in mission critical projects. So from an overview on Western Energy Systems, we integrate our power projects. We also maintain them with an extensive team of technicians, all factory trained. We also have our own factory trained facility in our Brea headquarters. That's Brea, California, for the Western Energy Group. We also monitor all the systems that we put in. The monitoring is 24 hours a day and 7 days a week. So let me summarize the results over the last 15 years that we've been in business. Over 100 gas engines in our fleet in California, but I want to emphasize here that also includes Alaska and Hawaii. We've got 200 overall in North America, and that includes the efforts on the part of our associates at Northeast Energy. 50% of our engines are sold to repeat customers, so that the emphasis here, of course, is the value that we bring to our clients, and they always, we believe they're always coming back because of the quality of our service and the relationships that we've built. We're the 2016, 17, and 18 Yenbacher North American Channel Partner of the Year. So again, our goal is always to be the best that we can be on behalf of our customers, and we provide a service that we'd like to think that is constantly improving on behalf of our customers. So from the standpoint, let's dive into this whole subject of combined heat and power. And my portion of this will be about the basics. So we know it's known as cogeneration or trigeneration, but the focus here is that it's on-site power generation. So it either is replacing or it's supplementing grid power. And certainly if you've seen the news lately, the challenges going on in the state of California with regard to brownouts, rolling brownouts, blackouts, and now with the devastating fires in the northern part of the state, you've got PG&E calling public safety power shutdowns, all in the name of protecting the consumer and the customer. But at the same time, those that have the benefit of CHP, they're still up and operating on the basis that they haven't had to evacuate. So the whole premise of combined heat and power is based on a single fuel. In this case, we'll use the example of natural gas used to produce electricity by fueling the generator, by fueling the reciprocating engine that then powers the generator that provides the electricity. The increase in the efficiency level comes as a result of using the thermal values coming off the engine, whether it be from the jacket water or specifically from the exhaust heat. The advantage here, again, is it takes it up to efficiency levels in the 80 to 90 percentile, potentially above in certain circumstances, but otherwise, basic engine performance is about 40% efficient. Benefits to the customer, you've got energy security, you've got resiliency and sustainability, reduced energy costs, and this is a critical factor, particularly in a state like California or Hawaii, for example, where energy costs are very high. We're able to, on average, reduce energy costs by as much as 15%, but it's all driven by a investment grade energy analysis that we do with our partners N2, who conducts that evaluation. We also do look at it in terms of there's reduced risk from uncertain energy prices, and Phil will get into that in just a few minutes as he talks about the case study on B. Braun Medical. Lastly, of course, is economic competitiveness, and we drive that point from if you look at it in terms of what we're able to save a customer on their electrical bill, they're then able to put that money back to work into their business. And we believe that helps make them more competitive in the marketplace, because money that was otherwise going to overhead can now go to their own internal performance and also improving their own customer base. So on a visual standpoint, we look at this, again, this is the evaluation or the picture of combined heat and power. So you start, of course, with air and fuel mixture. You put that into the engine. The performance gets through on the generator for electric energy. Then we go to, of course, thermal energy and the hot water, steam, and absorption chilling that helps improve on efficiencies and the performance of a specific plant. So that's the brief overview on combined heat and power. From here, Phil Baldwin will take over and begin the case study discussion of how Phil and his team, along with Western Energy, put together the project for B. Braun Medical in Irvine, California. Phil?
Thank you, David, and thank you, IEEE, for the invite and for everybody that's sharing their screens. Happy to be with you this afternoon and talk to something that's very dear and near to my heart, and that is combined heat and power. Been in the business since about 1998. Been involved in the design, construction, and implementation of about 41 combined heat power plants and about 6 or 7 larger 40 megawatt LM6000 projects, mostly peakers in the California area during the energy crisis. One of the things that has driven this market now in California, as David spoke to, is the really unreliable grid that all three of our major utilities are suffering with due to the fires. And basically, the amount of solar that we put on the grid, our peak period has moved from 4 to 8 or 9 in the evening, instead of being the normal peak period from 10 to 4. So it's had a dramatic, that duck curve change has had a dramatic change on the utilities perspective here in California, and has been very beneficial to us in the fact that we've been able to offer people better sustainability and reduced cost. I want to relate how we came about this B-Braun project. I had known these people for a couple of years, and then I got to noticing that their power plant was listed on our California emissions board's list of no longer going to be viable as far as emissions in 2021. And so I said, oh, they're going to be needing some help. So we got in contact with those folks, and sure enough, they were receptive to looking at. They'd already entertained CAT. They had 2 solar turbines in there that are 30 years plus. So they had already talked to CAT. So with today's gas rates, we were able to convince them that those 2 old turbines and the heat recovery steam boilers that they were using, they had just installed a new 5,000 horsepower boiler, which was much more efficient than those turbines for producing steam. So there was a better opportunity to put that thermal to use on a new plant for chilled water. So we got the interval data, the bills, and we put together a utility data information document that led us to feel like that we could use about 9 megawatts. So we sized 2 of our 4.376 Yenbachers and have 1 on each service. They have 2 services there now. So each one of those Yenbachers can provide about 1,000 tons of 42 to 44 degree chilled water, completely offsetting the operation of their central plant. So this became a very good project for them to consider. They were looking at the capital budget because they had an extensive expansion there on their facility during the last 2 years. So what we did is we went out and found a partner to come back and talk to them about an energy service agreement, or more commonly referred to as a PPA, power purchase agreement. So we partnered with AEP, American Electric Power, out of the Midwest, one of the largest utilities in the United States, about a $73 billion a year company. And they are, had just timing's everything. They had just officed a new office in San Diego. We're very motivated to put some behind the meter projects in California during this crisis. So we teamed up with them, put a proposal together. Took about 7 or 8 months to get all the lines, red lines taken care of, and the T's crossed and the I's dotted. But we're signed, getting ready to go to construction the end of this month. And hopefully by the end of 2021, we'll have a new 9 megawatt plant there doing about 2,000 tons of refrigeration. So when they were operating the turbines, to give you an example, on those aged turbines, their heat rate was about between 17 and 19,000 BTU per kilowatt. So not very efficient, but they were 30 years old. The heat steam recovery units were not as efficient as they should be. So as it turns out, the profit that they were realizing on those old turbines is just about what their fixed 15% discount for the next 15 years is going to be with AEP. So just a very good project for everybody. Good project for us, good project for AEP, and a real good project as far as reducing operating expense, maintaining the revenue that they had had before, and also an additional sustainability that they didn't have before, in that we cover about 95% of their base load. So real good project. This was a real good opportunity. They're not all this easy. The greenfield work is much more complicated, starting the process. But when you have enough thermal, that you can offset with either hot water, steam, or chilled water, these projects can be very, 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 very financially viable. So that's Bebron, one of the largest pharmas in the world, based in Germany, and one of the largest companies in the Irvine area. 2 blocks from my office. I love this project. So one of the things that Bebron was able to do in that power purchase agreement was fix their cost utility rate at today's rate for 15% discount over a 15-year period. Well, if you just look at historical data for SCE over the last 7-8 years, it's went up about 8 or 9 cents total. So they have a real good opportunity to hedge some future expensive cost and expense of electrical increases. So just a real good project for everybody concerned. We were real happy to work with them and looking forward to the commissioning in the fourth quarter of 21. The process involved removing their 2 old turbines, shown there at the bottom. They have 2 services now. So what we did is we put one of our Jenbacher 4 megawatt units on each service. Next slide. So this would be service A, and you can see there below the cooling towers, we have the absorption chiller on the left, and the Jenbacher with its radiators on top there, and the SCR, the heat recovery. So you can see that 1,000-ton chiller is pretty significant size. That Jenbacher container's 40 by 10. So absorbers can really be take up the space on the larger sizes. So that's service A. Let's go to service B. On the other end of the project, but adjacent to the service, both services are directly across the driveway from the power plants. Just a really good situation all the way around. This is just a mirror image reversed. We've got the Jenbacher on the left-hand side there and the absorption chiller on the right-hand side. These are very efficient chillers. They have about a 3.0 efficiency. So any questions on this particular project? And then we'll go into how the process proceeded. Okay, let's take them how we moved the project forward, David. Next slide. Once we arrived at our initial feasibility study, showed them what the design and development would look like, entered into a letter of intent that allowed for, we would provide the cost for the 35% drawings. We would go out, get contractor pricing, validate our financials, and if we were successful at that, they would agree to move forward with the project, or if they opted out, they would pay us for our engineering. They opted to move forward, so we put them together with cogeneration financing with AEP, and we look for those units to hit the ground about this time next summer, and hopefully have them installed and commissioned by the end of 2021. David, you can take them through the long-term service agreement that we have on that. That's the plant we're actually going to operate and maintain for the 15 years.
Okay, we've got Matt with us. Matt, you want to talk about the service operation?
Sure. So there are, this is Matthew Nisborski here, application side. We've got three different programs that we can offer. We can offer the basic program, which involves some of the on-site mechanics or on-site operators doing some of the smaller items, the spark plug cleaning and gapping, valve lashing, oil changes, things like that. We have a silver program, which Western Energy would, on the basic, we we would handle all of the big services, you know, the 10,000 hour services, the 20s, the 30s, you know, the big services where they require a little bit more knowledge than the standard operating staff has, unless they go to some training courses, which we can certainly offer them as well out of our Brea facility. The second one we offer is a silver program, which covers all of the planned maintenance that would be required throughout the life of the power plant. And then the next one would be a gold. Typically, when we get into the PPAs, we look at the golds because that is you know, it's a pretty, you know, there's a level of reliability there that you know has to be maintained, and when we have control of that through our, you know, our factory training and our factory parts and service representatives, it's that reliability is much higher. And then we have a platinum program which covers everything, including operations. So we would staff that facility, you know, on a daily basis for all needs. That's pretty much the basis of our. That's pretty much our packages there, Dave.
Great.
B Bronze funder opted for platinum plan, so we'll have an operator at that facility 24/7, 365.
Yep.
Excellent. All right, thanks, Matt.
You're welcome.
Thanks, Phil. So at this juncture, our formal presentation is concluded. So we're certainly happy to entertain any questions, comments that you may have. Maybe you've got some projects you're working on that may generate some questions from that. So please, by all means, fire away.
Hey, Dave, this is Mike. How about like utilities? Can you do work for PG&E?
We can. Phil, do you want to comment on that?
Yeah, actually, we responded to some PG&E RFPs for on-site generation to help them facilitate the reinforcement of their grid, particularly during peak periods and through these outages they're experiencing. So the answer is yes, we're qualified to work for PG&E, SCE, and SDG&E. So we can meet those qualifications and actually build projects for them.
So here's another one. We had a project down in LAX, the Raytheon buildings. There was 8 of them. During the summer brownouts, they asked us to shut down the facility. So would you guys go in and like do an energy audit to figure out what they could shut down and not get fined millions of dollars?
That's a good question.
It is. Go ahead, Phil.
Now, is this in reference to the power plant, or is this in reference to? I'm a little confused what the question is.
Okay, so at LAX, Los Angeles Airport, there's Raytheon owned. I don't know if they own it now. This was a couple years back. But they owned a couple buildings. They sent us in to figure out what can they shut off. And when you get the call from PG&E to shut down or whatever, Southern Cal, you got like a half hour. So they sent us.
They're on demand response.
So otherwise you get fined millions of dollars. So it was a big thing. But I don't know about today, but what can you shut off? You can't shut off the lights at the airport. You can't shut off the air conditioning. I mean, what generators? They can start up their Genbacher generators, I assume. You guys?
Yeah, I mean, I think the main utilities there at the airport, I think, has got a CHP taking care of the building, chilled water, hot water, and the emergency loads. They're really only answering this in this day and age is just like we did at Pittsburgh Airport, projects under construction right now, and we took 100% of their load off. So they're islanded now, and we've got about a 40 megawatt plant there, and we're also going to do their chilled water and supplement a little bit of solar and battery. So I think the only real answer is you better increase the size of that plant to carry 100% of your load. And they have the room out there. There's no reason they couldn't do it. Emissions wouldn't be very hard out there based on the emissions they already have with the airline.
As you know, we're up in the Pacific Northwest here. We have Microsoft. They're looking to go totally off the grid.
Mm-hmm.
Is that something that you could help us with? I mean,
Absolutely.
Microsoft.
Yeah, I mean, I think the answer is twofold. Yes, we can. I don't think natural gas is what they're looking for. I think they want to go carbon neutral. So I think they're probably more interested in this point of looking at wind and solar and some battery. Those are big facilities. They have combined heat and power on some of their facilities now, but I think eventually their goal is to have enough flyover state wind and solar to power their facilities. But they're always going to be in a situation where there's days the sun doesn't shine, the wind doesn't blow, and you'll never have enough room to back up 50 or 60 megawatts of battery, when that happens, and have the duration that you need. So can we talk to those folks about combined heat power? Absolutely. It wouldn't take much of a power plant to offset 100% of their chilled water load, and that's their biggest. They keep them at 68 degrees. So those co-location sites. So the answer is yes. We'd love to talk to them. We've bid a couple of their projects out in the Midlands, out in the no man's land. But if you have some resources there, we'd absolutely love to talk to Microsoft and put them in touch with our data center division, which David works with those folks all the time.
Right.
Okay, got another one. So I work with a lot of FAA engineers, and they're all up and down the California coast, Arizona, and Hawaii. They have a lot of small buildings. How small can you get? Like 150 kW? Is that too small for a natural gas engine, or is that not feasible?
Nope. There's actually cogen units that go down to 50 kW now.
Okay.
You would have just a little bit of jacket water there that you could do for domestic hot water, but 150 to 250 is really the small plant sweet spot. It gets difficult when you go below that. In California, if you had a real small building under 100 kW, there's no departing load or standby charges. So that's significant in California.
Mm-hmm.
So if you do have a small building, it absolutely pays you to look into it because the equipment's available.
Okay. So we do a lot of projects up in Alaska too. Does the Jen Barker natural gas have issues with cold weather?
No. Got a good example up there. We actually have how many megawatt plant is that?
Matt,
that's 5 times 1.4. What is that? 5 times 1.4. That's 7.5
megawatts or something like that.
Yeah, 7.5.
We have a plant that's been in operation up there for about 5 years out at the Air Base landfill, running on biogas. Mm-hmm. The answer is the problems haven't been with temperature. That's one thing about the sealed systems we have on the Embacher. They're not going to freeze and they're not going to boil. We do a lot better in severe temperatures than turbines do. Yeah. So the answer to that is yes, we'd love to do projects in Alaska. We have a established base up there. We've got a full-time sales rep up there.
Well, and Mike, we also recently did a proposal for another project up in Alaska, similar to that landfill project that Phil was referring to outside of Anchorage. So we view Alaska as go ahead.
Well, it's actually for utility, I think.
Yep.
We were doing some grid infrastructure stability with Yenbachers for utility. So the answer is yes, right. In Alaska.
Yes, exactly.
Okay, so I got another question. So we got a lot of clients down in California. Arizona, and New Mexico data centers. And we're doing like big 30, 25 K, no, 30 megawatt units, like 8 of them.
Sure.
So can you talk a little bit about diesel over natural gas? This is California, so I guess the price of diesel is pretty expensive, right? Well, electricity, is there a difference, I guess? Electricity, I guess the grid.
Yeah, I mean,
can you talk like what benefits would they have going with natural gas over diesel, I guess?
Okay, the main thing with diesel is you're limited to 200 hours a year. Then you pay pretty severe penalties on your emissions. Natural gas is a much better option. Even for backup, we have a 3 megawatt engine now that'll start in less than 10 seconds. So that's faster than any diesel. So basically, the transition period that used to be the big issue for natural gas isn't an issue anymore. We can transition as fast as any diesel backup, run a lot cleaner, and oh, by the way, we can run base load and still be there as backup with an N+1. So the answer on the data centers in California is there is a better option now. That is natural gas. That'll give you the stability and the reliability that you need out of the diesels. Burn a lot cleaner, can run longer without penalties. Price points not that much different, and we can also generate a little chilled water while we're running. So good option. The utility still maintains 12 to 14%, even in that cent per kilowatt hour, even in that space. Even at 10, 20, 30 megawatts, they're still looking at never getting under 10-cent power. So with today's gas prices, we can buy gas now on long-term contracts for about $3.50 to $3.75. So the spark spread is very good for those folks if they'd like to entertain a project. We'd love to talk to them.
Well, and Mike, if I can follow up on Phil's comment, is that sustainability is so important to a lot of these data center owners that this is one of the key factors, as Phil was highlighting, in terms of diesel versus natural gas. And granted, there's a lot of discussion about natural gas, but at the moment, it is the cleanest way to power these systems. And there's a good deal of very successful emissions control equipment that address all of the emissions factors that are generally brought up on the permitting side.
Okay, one last question from me, at least. You do have a project down in Sheridan Waikiki. You put in a gen block. I don't know how big it was, but so that was about 5-10 years ago. Any issues with it? And if there was issues, how did you handle them? Do you do regular maintenance?
Yeah,
because I know the answer.
That was an N2 project, and it's been up and running, Matt, for what, 2.5, 3 years now?
Yep.
Yeah. So it's never easy working on the island, but we were very successful there in being able to blend that bunker that we built for the new engines. There's 2 engines there. And that project was bundled in with completely upgrading their central plant. We put in new electric chillers, a new absorption chiller, all new boilers, pumps, and controls, and cooling towers. So a very extensive project. Sheraton is real happy. They wish they had somebody to share the power with, because they kind of overestimated what their load was going to be, so we have a little excess power there. But it came in real handy when they had that storm 2 years ago, knocked out all the power. They actually rode that storm out without any outages, took some jumper cables across to the facility next door, and actually kept a next door neighbor up and running during the storm. So project worked out real good. Maintenance has been no problem. Like I said, they just have a little excess power there because of some calculations on what they thought their load would be. But a real good project for everybody. Any of your clients or IEEE people that would be in Honolulu and like to see that facility, we'd be glad to set up a tour so they could see it.
Great. Mike, do you have any other questions?
One last question. So you guys doing like generators, and is there any just building savings, or you said you do energy audits?
Mm-hmm.
Is there any other besides generators?
Yeah. We look at, when we do our audits, we look at everything.
Lighting.
So, yeah, what we're considered is supply. We do supply. All the other options out there are on the demand side. So that's more efficient lighting, more efficient controls, more efficient electric motors, variable speed drives on those motors, power factor correction, harmonics mitigation. We look at all that stuff. So if there's an opportunity to do all those things, we usually look at that first because it lowers our demand and can have an impact on the size of our engine. So we always want to look at the demand side first and make those calculations on what that reduction might be, then size the engine and make a bundled proposal to take care of all their energy needs on the site. And by the way, those initial energy audits are on us. We don't charge for those.
And you guys you represent Jen Barker, right? Correct?
Yes, that's right.
So do you do any PV, wind, or thermo? Thermo being just an alternate type of energies.
Yeah, we've done ORCs, which is, waste heat, the utilization of waste heat into a generator, small steam-driven generator off the heat. We've done that. We've done some solar. To the best of my knowledge, our company's done no wind yet. We're not really real situated for that, but the answer is that we still have a good relationship from our former owners, GE. So if anybody has a wind project, we'd be glad to bring in the GE guys. They're major players in that space. And we really try, I kind of joke about the project will drive the technology. Sometimes there's only an option for a small grid of solar and battery or a small cogen with just hot water. But our approach to that is kind of agnostic. We like to look at what fits the project the best. It just so happens that 9 times out of 10, it seems to be a Yenbacher. So we think we have a good quality line there, but I've been in situations where there's a turbine was what fit best because of the steam load. So we put a turbine in. But we usually find that most conventional combined heat powers lend themselves to a reciprocating engine doing either hot water, steam, or thermal, chilled water. So,
where do you see the industry going 5 to 10 years from now?
Well, for my part, I think in California it's a lot different than the other 49 states. New York will probably be closely behind us or try to be, but I don't think anybody will catch us for the next 20 years. But, we actually have cities in California putting ordinances into effect where there'll be no gas in new buildings. City of Berkeley, Hayward, some of the other people are jumping on it. So do I think there'll be an end to gas? No. Propane's a gas. Natural gas is always going to be used in some instances. The nice thing about it is over the next, we're looking at being carbon neutral in California by 2035, 2040 at the latest. So I think that we have a good run of the next 5 to 10 years in doing combined heat and power with clean natural gas.
And Mike, there is an effort on Yenbacher's part to be able to take hydrogen to power the reciprocating engines. So they're expected to come out with at least one engine and potentially a series of engines that could take hydrogen. But again, to Phil's point, natural gas isn't going anywhere in the near future, at least I don't think in our lifetime. So NEO is, and Jenbacher specifically, are always making an effort on their R&D side to keep ahead of the curve. And that's where the hydrogen comes in. But as to Phil's point, natural gas right now is at a great price, and all the emissions factors can be easily handled through SCR equipment and meet the emissions requirements that are laid out by the state.
You mentioned cells, thermal cells. I know Microsoft's doing a partnership with McKinstry to do cells. Is that
fuel cell?
Fuel cells. So, and you guys do that too?
Yeah, I mean, we don't feel like
design.
Yeah, it's basically just because of the emissions and being carbon neutral because of the exhaust, but they're not very efficient. You know, there's only one that you can utilize the thermal. Everybody else is just generating power off natural gas, and they don't give you any thermal. So they're about a 4 to 5 year span, and then your maintenance program is basically priced to replace the equipment, because it has about at most 5 to 7 year span, and the price that you pay for maintenance is kind of replacement. You know, they just go along and replace the major components, and at the end of 7 years, it's new, and it'll go for another 5 or 7 years. But very expensive maintenance program, because it's basically is equipment replacement. But to answer your question, yeah, we've installed fuel cells. We will probably install some fuel cells in the future, but it's not our best option, we feel, for the customer, unless carbon neutral zero emissions is just the driver.
Right. Okay.
So we want to wrap it up?
Yeah, any other questions?
Yeah, I mean,
any other
go
questions
ahead,
from the group? Okay, let's
thanks again for
let's wrap it up.
for
We're gonna
IEEE.
have a door prize here from Salis O'Brien. We got the coffee mug or the kitchen utensils. And Dave, give me a number from 1 to 7.
6.5. No, 7.
7. Dave Woodward, you won. So you get to choose one.
All right.
So
Thanks. That's Daryl. Yeah.
Congrats.
Okay.
I'll get with him and send it out to him. Well, once again, we thank you for joining us. We thank you, Western Energy Systems and N2 Energy Solutions, Dave Muller and Phil Baldwin. We thank you for presenting today. And
Yeah, our pleasure.
This will be posted on the web, so anybody or your colleagues can take a look at it. And we appreciate everybody's time today.
Great, Mike. Thanks for the invitation. Certainly appreciate the opportunity. And everybody have a great weekend.
Thank you,
folks.
Thanks.
Have a good weekend.
Okay, bye-bye.
All right. Thanks.
Bye-bye.
Bye.
+1714767